Right then, welcome along. It's time for a brand new episode of the Fun Kids Science Weekly podcast. My name's Dan, thank you so much for listening. This week, on the only show in the universe that guarantees to uncover all the true secrets lurking in the universe, we'll have a look at a volcano that spews out blue lava. Also, we'll talk about why it turns out we might have misunderstood the humble moth. And I've got some of your questions to answer as always. This week they're on trees, milk and fire. It's all on the way after we dive into it with one of our favourite geniuses on the show. This is Professor Hallux.
Professor Hallux's Pathology Puzzles with the Royal College of Pathologists.
Now, I know you love Time Stop, Crime Stop, but you have to turn it off because I've got some pathology puzzle cards here.
Brilliant! I love a good medical mystery. What have you got?
OK, here's a good question. Why, when you have a blood test, do they take blood in several different tubes?
Well, when you have a blood test, the chances are that your doctor has asked for several different tests to be performed at the same time. Different tests may require several samples because different bits of the blood are tested. It's just easier and safer to have separate samples.
Here's one about forensic pathology, the sort that's all about dead bodies, just like in Time Cop, Crime Cop.
Nanobot, how many times do I have to say? The name of the show is Time Stop, Crime Cop.
Whatever. Does everyone have an autopsy when they die?
No, about 1 in every 5 people has an autopsy after their death. The most common reason for an autopsy being requested is that the cause of death is not known. Perhaps the person who died hadn't seen a doctor for a long time, or their death was sudden and unexpected, or was being investigated by doctors but a diagnosis hadn't yet been made. It's in situations like this where there is a puzzle or a mystery about what's happened. This is where autopsies are performed. They're carried out by specially trained doctors called histopathologists who have to study for over 10 years before they can be forensic pathologists. They're brilliant at cracking the case.
Right, final question. It's about health screening. Our genes carry lots of information about us. So is there a genetic test that can tell what diseases I'm going to develop in the future?
It is possible to test for certain conditions because the evidence is right there inside the genes in our cells. But most diseases are caused by a mixture of causes, so it's not quite so easy.
Well, whatever the pathological puzzle or the medical mystery, it's good to know the pathologists are on the case.
Professor Hallux's Pathology Puzzles with the Royal College of Pathologists. Find out more at funkidslive.com/Hallux.
It's time for my favourite part of the show. It's where I turn into a little science Sherlock and I do all the research, answering the questions that you leave for me as a review over on Apple Podcasts. First up today, we've got H2O, not their real name, who asks, why are some trees evergreen? Now, evergreen trees tend to keep their leaves all year round, or they drop off bit by bit over the course of 12 months, whereas deciduous trees, they lose them in the autumn normally. Now, it's all about where they came from and how they photosynthesize to make energy. You see, deciduous trees, they close up the holes all over their leaves during winter when there's not a lot of sunlight about, so they don't lose water, and they need that sunlight for energy. They also take away a pigment called chlorophyll that absorbs the sunlight, and the combination of those two things makes the leaf drop off. Whereas evergreens, they first came from cold climates. They've had to adapt to having not a lot of sunlight all year anyway to stay strong. Their leaves are thick and strong, usually straight like needles. Think of a Christmas tree. Those are evergreens. And it helps them keep water all year round where there's not much sun, so they don't need their leaves to drop off. Thank you so much for that. This is from Oren 2014, who asks, why is milk white? Well, we know that white light is a blend of a lot of different light wavelengths, aren't they? It's a mix. It's not straight red or green or blue. It's a whole mixture of loads of different colours. And we see colours off of things because substances absorb or reflect some of the light. Now, milk is filled with fats, and a calcium-rich protein called casein. And those two things mixed together reflect a wide range of different coloured wavelengths, so they make it appear white. And finally, this is from Ryan George DV, who asks, why does oxygen catch fire? Well, technically, it doesn't catch fire itself. It's not flammable, unlike some other gases which do catch fire. But oxygen is an oxidizer, which means it helps things burn. It works with the fuel to react with the heat, the other stuff that you need to make a fire, and when they work together, it makes the flame. You think of it think of it like fires are breathing in oxygen, just like we are. It's oxidizing it, breathes it in, pumps out other gases. Doesn't catch fire itself, but it helps flames burn. Thank you for those questions. If you've got something that you want answered, you need to leave it for me as a review for the Fun Kid Science Weekly over on Apple Podcasts. It's the Fun Kid Science Weekly. Now, one of the things that we're all about on this show, the reason we're here, it's finding different ways to bring science to life. And our guest this week, thankfully, feels the same. Dr. Dude is part of the Mad Science Show that tours all around the country, around the world as well. And they are improvising. Now we're all stuck at home, and he's here today to answer some of our chemical questions. Hey, Dr. Dude.
Hey, good afternoon. How are you?
Yeah, I'm very well, thank you. First question, I'm gonna just chuck at you a hodgepodge of different sciencey chemical stuff that I think we're a little bit confused about. All right?
Excellent. Good. Put me to the test as well.
What actually is a chemical reaction? Why do two different chemicals react together? What's going on in their atomic structure deep down in the elements that's making this happen?
Well, that's the key to it. Essentially, it's we always break it down. A reaction is a change, so we are seeing something change. So a chemical reaction essentially is a collision. So if you imagine everything in the world, including us, we're made of atoms. They're like the Lego blocks of life, if you like. So when we have a chemical reaction, those atoms collide with each other. And what they do is they change in one way or another. So either there are new bonds formed between those atoms and those molecules, or they are broken down. So it's basically a change, like you said, in almost like the atomic makeup of what is going on. A really good example of a chemical reaction is rusting. So if you leave your bike outside in the rain or the snow, and what happens is that the metal, those atoms, they mix with the oxygen atoms, and they make a brand new substance, if you like, a brand new material, that orange-brown material which we know as rust. And that's the mixing of oxygen, and that's why we call it oxidation. So yeah, I guess the simplest way to put it is the atoms collide and they change. So they either break down or they build up and they make something brand new.
What's the point of this? If almost everything around us exists because of some form of evolution, usually for a purpose. There is usually a reason why things that happen in the universe happen. Why does oxygen? Why do we need to make different chemicals, different compounds?
I think for all sorts of different things, two things mixing together, especially in medicine, where we use science in medicine, mixing different atoms, mixing different liquids, mixing different things together are always going to make something new. And it's from a scientific perspective, can we use that something new for good? Bringing it back right down to basics with what we do for like Mad Science, for example, if you mix vinegar and bicarbonate of soda together, you get carbon dioxide, and it can blow up a balloon without even touching it, and it looks like magic. So it works both ways, really. But I think it's very important to have those new things, because as we always discover new things, we can then look at where we can use those in the world today.
We do know that some chemicals and substances are more reactive than others, though. What makes one thing much easier at making new things than something else?
I think it comes down to its makeup, basically. So we could we delve into here more about sort of acids and alkalines. So with something is very acidic if it has lots of hydrogen atoms, which are very, very reactive and very, very responsive. Something that is an alkaline will have lots of hydroxide atoms, and those two things do like we said in the beginning of the podcast, is they collide and they react very, very quickly. So something that is more volatile, like hydrogen, will react much more than an alkaline, which alkalines tend to be a little bit, I say weaker, but I mean it in a different version of chemical rather than actually being. We get very, very strong alkalines and we get very, very strong acids. So the stronger they are on the pH scale, for example, the more likely they are to react with something else.
Talk to me about this pH scale. How do we figure out where one liquid is on this scale rather than another?
Yeah, so the pH scale is really, really cool. I mean, it's one of my favourite things to do in science. And we use something like universal indicator, which essentially indicates if something is an acid or an alkaline. So pH stands for the power of hydrogen. So when we test these chemicals, the universal indicator will change colour depending on how many hydrogen or hydroxide atoms are in a chemical. So, for example, a very, very strong acid would be 0 on the pH scale, and that's a bright red colour. And that would mean it contains lots and lots and lots of hydrogen atoms. And then we go to the other end of the scale for a very strong alkaline, we would call pH 14, a really deep purple colour. And that has a lot less hydrogen atoms and much more hydroxide atoms. So we get a real vast array of colours from 0 to 14. And obviously, smack bang in the middle, water, for example, is a nice neutral green colour, and they are the neutrals. So essentially, the pH scale will test the amount of hydrogen atoms in a chemical, and it will show us that through a colour key, if you like.
And earlier on, you spoke about being able to blow up a balloon using bicarbonate vinegar. That's one way we can see a chemical reaction. What are other ways that we know a chemical reaction is happening? What's going on?
So essentially, there are 4 key things that show us a chemical reaction has taken place. So they are temperature. So we might get a change in temperature. So something will turn hot or something will become cold. We might get a change in colour. So it might, like the pH scale, for example, it might change the colour it is completely. We might get a brand new substance, which is it changes what it is. And that goes back to our first question about what causes a chemical reaction. That collision actually creates something brand new in the structure of the atoms. And then we also get a gas being given off. So obviously we can't normally see gases, but like we spoke about, the vinegar and the bicarb experiment, they mix together, they create carbon dioxide. If you put a balloon over the top, the balloon will inflate itself. So although we can't see the gas directly, we know it's been created because the balloon blows itself up. And I use a little song to help me remember. And when we're doing mad science, so we say a chemical reaction we know has happened if we see a temperature, colour, substance, gas. So one or more of those 4 things will show us a chemical reaction has taken place.
It's always good to have a song, I think, to remember these stuff.
Absolutely, it certainly helps me.
Speaking about making new things, are you all right to talk to us about energy a little bit?
Yeah, absolutely. Yeah, fire away.
With renewable energy, when we take energy that's made by the sun, how do we do that, and how do we keep it and then reuse it again?
Yeah, so obviously this is it's quite a big passion of mine, and I know of mad science and of a lot of people in general is, switching to these renewable energy sources, and one of those, which we can use over and over again, is the sun. So people that are listening, you might have seen solar panels before, and they can be like the big ones that sit on the roof of houses or schools or buildings. You might have even seen solar farms, which are often found near the coast or on the side of motorways, big fields that are full of solar panels. And also on a much smaller scale, you might have them on the little LED lights that light up your path in the garden. So what happens is those solar panels, they absorb the rays from the sun. So they absorb those UV rays and they store them as what we call DC. Now, direct current. Now, direct current is very, very powerful. It's very, very strong, and it's not much use to us in that form. But what we do is we use a little machine called an inverter, and those inverters change that really strong direct current to AC, which is alternating current. And that is the electricity that powers our homes, our schools, our workplaces, and things like that. So it basically completes a circuit, if you like, if we want to think about it from a science perspective. So the sun shines, it hits the solar panel. Solar panel absorbs those UV rays. It sends it along a wire to our alternator, and then that alternator changes it to AC, and it goes along another wire to its end. So that might be our house, so the Xbox, the TV, the fridge, the freezer, the washing machine, and that sort of thing. And on particularly, sunny days or where we have long, bright spells of sunshine, that energy, rather than going directly through the alternator, is then stored almost in like a little side compartment. And when there's less sun, that solar power is released through to the alternator and then goes on to carry on powering things.
Now, you mentioned that Mad Science are really passionate about that. Usually you kind of tour around the countries doing these science shows with the songs and everything. What are you doing now while we're in lockdown, while we can't really do that? How are you keeping us learning?
So essentially, we've set up in my spare bedroom, we've set up the Mad Science Lockdown Lab. And what we're doing with that is we're live streaming every other day during the week. So we go live every Monday, Wednesday and Friday at 11 a.m. And that's a chance for people to sign on and watch us. And that includes doing follow-along experiments with me in the Lockdown Lab. We ask you to bring equipment along so you can join in. You're more than welcome just to watch as well. And we also give activities to do at home. Some of them might need to be done outside, which we recommend. So yeah, there's a real mixture of follow-along activities, doing things yourself at home, and just watching me do my own experiments. So if I'm allowed, the website is east.madscience.org, and everything is on there. There's some free content that you can watch that we did previously as well, including a dry ice show, and we also did a show recently with a water provider about what you should and shouldn't put down the sink and down the toilet. So as well as some free content on there, there's also those live streams every other day that you can come watch and enjoy.
east.madscience.org. Amazing. We'll check that out. Monday, Wednesdays and Fridays. Dr. Do, thank you so much for joining us on the Fun Kids Science Weekly.
Lovely. Thank you so much for having me.
It's time for this week's Dangerous Dan, where we're headed to Indonesia to take a look at a volcano that spews out bright blue lava. It's called the Kawah Ijen. Now, technically, it spews out that bright blue lava, but there is a reason why it does that. It's not perfectly as it seems. We'll have a look in just a sec. Now, the volcano is part of the Pacific Ring of Fire, we've spoken about before on the show, a long line of volcanoes which you find over in Asia, and they're ready to burst flames out. Now, at the top of the volcano lies a huge lake in the centre of the crater. It's 1 kilometre wide, it's 200 metres deep, and the water that it is filled with is highly acidic. It's filled with a sulfuric acid that bubbles out of the earth. And it's this stuff that makes it look blue, because when the sulfuric gas that rises from the acid catches fire when the volcano erupts, it makes a blue haze. We were speaking about how we find colours earlier on in the show. The lava that spills through the gas looks blue too. So the lava really isn't blue itself, it just looks blue through this gassy haze. It's cool, it's amazing, and it's a volcano, so perfect for our Dangerous Dan list, I'd say. By the way, very quickly, if you love listening to the Fun Kids Science Weekly, I think you'll really enjoy a brand new podcast that we've made. It's called Sports Squad. It's so easy to find. Have a look wherever you're listening to this. Just search Sports Squad. It's presented by Ao and Chanel, and twice a week they chat to sporting superstars, real top athletes and sports coaches to help get advice and some tips for staying fit and active right now. So far, they've spoken to Olympic gold medalist Chris Hoy, Olympic gold medalist Rebecca Adlington, expert tennis coach Judy Murray, whose son is Olympic gold medalist Andy Murray. In the most recent episode, it's netballer Tracy Neville. Again, if you want to listen, just search Sports Squad wherever you get your shows from. It's time to get a brand new series on the show, and I'm starring in this one. It's not just me, it's also the Thunderbirds. The Thunderbirds from Tracy Island. KO and Brains, they've agreed to take us, you and me, on a trip to Tracy Island and also to the Red Planet to have a look at Mars and how scientists are trying to explore Mars and learn all we can. It's time we're taking a trip with Thunderbirds Go, Mission to Mars.
5, 4, 3, 2, 1.
Thunderbirds Go, Mission to Mars.
I still can't believe I'm here on Tracy Island with International Rescue's KO and Brains. Thanks so much for helping me find out about the ExoMars mission, guys.
You're welcome. We know kids love finding out about space. And Brains, well, he's kind of a big kid anyway.
I'll take that as a compliment.
So, and I know this might sound a little basic, but spacecrafts are quite big, especially when they have to carry heavy payloads. How do they get off the ground?
Getting off the ground is the hardest part of any mission. Isn't that right, Brains?
That's right. It's all thanks to gravity. Or no thanks to gravity.
Gravity, that's like a force, right? It pulls us down to the ground and stops us flying off into the air.
That's right. To launch and leave Earth's gravitational pull, an object will need to reach a speed of at least 7 miles per second. That's 25,000 miles per hour. At that speed, you could travel around the Earth in 1 hour.
Guessing you need a pretty special engine for that and a lot of fuel.
Yeah, and that's quite the challenge too. Here on Earth, engines use air around them to ignite the fuel, like Thunderbirds 1 and 2. But in space...
Let me guess, no air in space?
That's right. And whilst there are some cool engines that can do both...
Like the pretty clever hypersonic jet called Sabre. That's got everyone very excited.
To get into space, you need a craft with a different type of engine. A rocket engine like Thunderbird 3. ExoMars will launch using such a rocket. A Russian proton rocket, in fact. A proton rocket is huge. It weighs more than 700 tons and is 58 meters tall. That's like 10 giraffes standing on top of each other. The ExoMars equipment is just a tiny part of the very top, where a surface lander called Kazachok and a rover called Rosalind Franklin will be safely placed in a descent module, which itself will be placed within a carrier module.
That's a lot of rocket.
It needs to be. Whilst Thunderbird 3 is designed as a vertically launched SSTO, that's a single stage to orbit rocket, the Proton needs 4 engine stages to help it get off the Earth. Each stage being used for no more than 340 seconds before falling away and burning up in the Earth's atmosphere. Once free of the Earth's gravitational pull, the carrier module will be able to travel on its own, using smaller amounts of propellant to push it towards Mars. It will communicate with Earth and be instructed to alter its navigation if needed.
So it doesn't have a pilot? Shame. That sounds like quite a cool job.
There's nothing quite as exciting as traveling into space, but distant planets mean long journeys, and long periods in space can be harmful. Not just to your body, it can be very tough mentally.
John Tracy has to spend long periods of time in space on Thunderbird 5, and I know he misses his family a lot.
Besides, carrying crew plus all the supplies needed would mean a heavier load, and that means more fuel would be needed.
And more fuel
makes the load even heavier, which is why it's hard to travel deep into space. The fuel will basically just be too heavy. International Rescue have travelled to the Oort cloud, far at the edge of the solar system, but that took a very particular kind of expertise and engine, and it was an extremely risky and unlikely mission.
This might interest you. Check out this cool type of propulsion. It's called Light Sail 2 and uses sails like a boat. But rather than wind, the sails catch light from the sun. It doesn't need to carry any fuel at all.
So after launch and travelling through the solar system, a whole 9 months later, the carrier reaches Mars. How does it land?
So the surface lander and the rover are tucked inside a descent module.
Which is attached to the carrier module that's done the job of getting them all to Mars.
Correct. When it reaches the right coordinates, the descent module will leave the carrier and begin its journey to the surface of Mars.
Easy. Only joking. I'm guessing it's anything but easy.
Scientists have learned a lot from past missions, but yeah, it's almost as difficult to land as it is to launch.
And this is before the rovers even moved one wheel on the surface. Now, I've got some questions about that.
I thought you might.
Thunderbirds are go, mission to Mars, with support from the UK Space Agency and International Rescue. Find out more at funkidslive.com/space.
Let's get this week's Science in the News. It turns out that moths have been badly misjudged. Scientists have found new research which suggests they play a vital role as crucial pollinators of a wide range of flowers and plants. It shows they travel much wider and further than we really have ever seen before because they do it overnight when no one had really noticed. Also, India's carbon dioxide emissions have fallen for the first time in 4 decades, and not just because of the current lockdown. More renewable energy on offer has meant people needed to use less fossil fuels, and then when the country went into lockdown a few months ago, it tipped their huge emissions growth into reverse because people aren't using cars and bikes as much. And finally today, modern humans began to edge out the Neanderthals in Europe much earlier than previously thought. Tests on remains that were found in a cave in Bulgaria suggest that Homo sapiens, which is what we are, we were there as early as 46,000 years ago, which is 2,000 years earlier than the evidence we had before. So this might change what scientists think about why the Neanderthals went extinct, and they will look into that more in the next few months. And that is it for this week's Fun Kids Science Weekly. Thank you so much for giving us a listen. Remember, while you're stuck at home, if you are going to go outside a little bit more often than perhaps you've done for the last few months, and you want to make sure you're staying as healthy as you really can, and make sure you're staying aware. If you want to wear a face mask because of that, you can get some tips, a nice guide for making your own face mask over on our website right now, which is funkidslive.com. I reckon you should have a look at that. While you're on the website, you can hear so many of our brilliant science series that you've heard so far on the show. We've got loads more podcasts on there. You can get them all on the free Fun Kids app, wherever you get your podcasts as well. And Fun Kids are a children's radio station from the UK. You can hear us all around the country on your DAB digital radio on that free Fun Kids app. And as always, at funkidslive.com. I'll see you next week. Bye.